dear students, welcome back to my class. In the series of learning programming in C, in the previous video, we have discussed about null pointer. In today's video, we will proceed with the same types of pointer and we will discuss about dangling pointer. So what is dangling pointer? How to handle this dangling pointer? Let us understand with small example programs, and we'll also see how it is going to work practically also. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Watch the video till the end. Do not skip the video. And if you like the video, please click on the like button and share the video to all your friends. Dangling pointer. So what actually this dangling pointer is? It is a pointer which points to a memory location which has already been deleted or freed. So we allocate the memory with the help of some functions like calloc and malloc. So once the memory allocation is done, it has to be freed so that it can be used by any other programs, dynamic programs. So if that memory is freed and if we try to access such kind of memory through pointers, then those pointers are called as dangling pointers. So here there are three ways in which a pointer behaves as dangling pointer. Those three ways are deallocation of memory. That is, when we deallocate the memory and try to access that memory, then that pointer cannot point to any memory, then it acts like a dangling pointer. It behaves like a dangling pointer. Then, function call. In function call, if we try to return some pointer value, if we don't get any address to point, then again the pointer behaves as a dangling pointer. Then, variable goes out of scope. We will be trying to access some address through some pointer, and if that pointer is pointing to some garbage location, then again that pointer acts as a dangling pointer. Let us understand all these three ways with small program code. So deallocation of memory, that is, we allocate the memory through calloc and malloc and store that address into the pointer. Then later what we do, we free that allocation. Look at this example. You have a character pointer and this character pointer variable is not pointing to any location, but by default if I just declare like this, it will be pointing to some location. So it's better to make it as null. So we have discussed that in the previous video, that is null pointer, why we have to assign null to a pointer. Please do check out the playlist. Now I say character pointer, I say ptr equal to character asterisk malloc function to allocate the memory. Well, we'll discuss about this calloc and malloc, that is dynamic memory allocation, in separate video in detail. So here just understand, I am trying to allocate the memory for the size of character type through malloc function and typecasting to character pointer and storing that address to pointer. So I will have a pointer. So that pointer is getting that new address. So I have a pointer ptr. Now I say malloc function is allocating some amount of memory to the size of character type, means 1 byte of memory. So it is pointing to this memory. Say the address is 100. So this address will be held here. So ptr. So this newly allocated memory address will be stored to this pointer ptr. So now ptr is pointing to 100. So that I can store character type of values. Next what I do, I simply say free that ptr. So free is one more function which is going to deallocate that allocated memory. So this pointer gets freed, it will not point to any location. So it will be freed. It may point to some junk address, some address. So it is freed. And now if I try to just put some value here, I say asterisk ptr equal to 10, then your program may behave differently. You may get some error. So ptr is freed, pointer is freed, and if I just try to access or store some value into some location, well, of course it is going to point to some junk address there, say some address say 2000, and there I may store, but that address may be utilized by some other program. But this PTR which was pointing to the location 100 is freed now. Now the pointer is in a dangling condition. This is what dangling pointer. Let us understand how this dangling pointer will behave in function call. So when I say you have the function definition, this is what the main function. Inside the main function, we have a pointer variable PTR. And I am saying asterisk PTR equal to function call. So the name of the function is func. So as soon as the function call is encountered, the control will be to the function definition. So I come to this point. So as it is a function which is returning a pointer, so the result that what I am going to get for this function call will be stored into a pointer. Means it is going to return a pointer. So hence we say asterisk and I say func parenthesis function definition is there here. In this function definition, I have a local variable x. I have created a local variable x and the value stored in that is 10. Say the address is 100 for this. Then what I'll do? I'll say return the address of x. So what is the address of x? It is 100. So it is a function which is returning a pointer. I say return the address of x means this function call should return this address to the place where function was called. So now the control will come to this point. Now the value 100 should be stored in the pointer. So now PTR is having the address 100 means it is pointing to the location 100. Right. Now what I'll do? I'll simply say flush standard input. So I'm going to flush the input in the sense I'm going to clear the memory. Then I'll say printf %d asterisk PTR. So when I say I'm going to flush the standard input, so the value that what I returned here, I'm going to flush the standard input. I'm going to clear it. Then when I say asterisk PTR, then PTR will not be having 100. It may point to some junk address and some junk value I'm going to print. So the output for this program will be some garbage value, some junk value. So here in this case, the pointer is acting as dangling pointer because the memory is flushed and what it is going to point? It will be pointing to some junk location and inside the junk location, obviously you will have some garbage value. This is the second way like how the pointer behaves like dangling pointer. The third way where the pointer behaves as dangling pointer is when the scope of the variable goes out. Now, observe this small piece of code. I have a pointer variable PTR. So, I have PTR. Then I have a variable X. Say the address for, well in fact the pointer variable will also have address. Say I'll just say it is 200 and X I just say it is 300. If it is 16-bit machine, obviously it takes 2 bytes. So this is 2 bytes means 300 and 301. 2 bytes of memory. Now I say PTR equal to ampersand of X. What is the address of X? It is the first byte address we need to take. It is 300. So now PTR is pointing to this location. Now I'll say printf an integer value at the location asterisk value at the location PTR. So PTR is pointing to 300. Now what is there in 300? Nothing. We have not stored anything inside X. So here again this pointer is behaving as dangling pointer. So these are the different ways like how the pointer behaves as dangling pointer. Now let us see all these things practically.
So here is the program to understand the dangling pointer. Let us understand the first way in which a pointer behave as a dangling pointer, which is dynamic allocation of memory. So here we have a pointer variable and we have allocated the memory through malloc function. So as soon as we allocate the memory, I am just clearing that memory using free function. So I say free PTR means what happens? The memory will be deallocated. Now what I'll do? I'll simply try to access that data. I'll say printf %d Then I say PTR. Then the same way I say printf %d asterisk PTR, value at the location. So what I should get here, for the first one, we will get junk address, and in that junk address we may get some junk value. So let us save this, run the program. See, you have some junk address 202136 and a junk value say 24. So this is how a pointer becomes a dangling pointer. So here we have the complete program. To understand the second concept, that is the second way in which the pointer becomes dangling pointer, which is function call. So here we have the function definition, then the main function, we are calling the function, and this function call should return a pointer, and immediately when it is returning a pointer I am going to flush the standard input. Then if I try to access, I am going to get garbage value. So let us save this, and here let me clear the screen. Now run the program. See, it is giving you a warning message saying that function returns the address of the local variable and it is not getting any value. So here is the third method wherein which the pointer behaves as dangling pointer, which is variable which goes out of scope. So we have a pointer variable and a normal variable x. Now I say ptr equal to ampersand of x. Now what I'll do, I'll simply say printf %d asterisk ptr. Well, we have initialized the pointer to store the address of x, but in the location x there is nothing to print. So if I try to print the value of asterisk ptr, that is value at the location ptr, there is nothing to print, so you get some garbage value. So save this program and run this program. Let me clear the screen first. So run the program, look at here, you get some garbage value. See, some garbage value, you got 3342 336. So this is how a pointer behaves like a dangling pointer. So hope you have understood with dangling pointer. That's all for today's video. See you in the next video. Till then, take care. Bye bye.